All right, good morning, everyone. Very energetic start to the day with that chat. Everyone is 11 a.m. Everyone is pumping. I'm surprised after a long weekend that everyone's still not half asleep. So you've got me today for the lecture. Jake is away and he couldn't do the lecture today. He left you a pre-recorded lecture for yesterday because it was a public holiday. Then you've got me today, and then on Monday, Jake is back. And probably very much jet lagged, so he'll be falling asleep as he is going to be coding, which should be fun. Okay, so can I have? Well, I can't have a shower of hands because I can't really see any of you. But can I please have a little in the chat? Can you let me know if you've watched the pre-recording that Jake has left you, just so I know, because Jake covered a whole bunch of control flow. And today's lecture is going to make absolutely no sense if you haven't watched that. Amazing. Okay, so if you have watched it, if you have not watched it, half of it so far. Okay, so I'll try to kind of like go back if we need to go back. Just let me know in the chat, and then I'll give a little recap and then we'll push ahead as well. So I'll try and keep it short and sweet, but not really because we've got 2 hours. But the recap, short and sweet. All right, let's do it. So I'm going to use Jake's lectures. So this is going to be wild because this is not my lecture notes, but we'll just go with it. And then I'll just expand on everything I want to say because yay. Okay, so what Jake did in the pre-recorded lecture, you might have heard a door knock and in the last 3 seconds of it because I was hungry and was trying to go for lunch and I wanted to see if he was available. So sorry about that. But other than that, what he did do is the control flow. He talked about if else, so your conditional loops. So asking yes or no questions and being able to move through code by switching off some lines. So if the answer is yes, do some bit of code. If it's no, then skip some line of code basically. And then he also started the first little bit of while loops. So how do we kind of go through repetitive code? And we will do a little recap as we go. And scans, I guess he did how to scanf something in the first lecture, so you're able to take in input from the terminal. So today we're going to look at some nested loops. So we're going to look into a while, inside a while, maybe inside a while, who knows how far we can nest. Well, you can nest very far, but then it makes your code very unreadable. So we don't really want to do that, but we will talk more about that. And we're also going to do some custom data types. So we're going to talk about something called structs and enums today. So 2 more data types. And I think you've done, what have you done? You've probably done ints and chars and doubles. And so we're going to look at 2 more things today. Okay, I think Breeze posted the live lecture code link, and it's whatever has Sasha and then dash. That's going to be the code that we're going to do today. So let's do a little if statements recap. Basically a way for us to switch statements on and off, and to be able to control our code a little bit better, which I guess makes sense because it's called control flow. So that's really how it works. So basically sometimes we want to make decisions and it's based on whatever information we have, and the if statement lets us branch between 2 sets of conditions in our code. So if some condition is met, then we will do something else. If another condition has been met, then we might do something else, or else if none of those conditions are met, then we have an else statement, which allows us to do if these 2 are not true, then this one will be done for sure. So if the first condition is met, then we will do whatever is happening here, and then we're not going to do any of these ones, and so on and so forth. So it really allows us to control what logic we want to use in our code. So a decision is basically any time that you ask a yes or no question and you need a yes or no answer, and it allows you to use an if statement to help make that decision. So I always like to use, is a number even? Yes, it is. Then do something. Otherwise, don't do it. And so on and so forth. So it allows us to really control what we're doing. Okay, I might use the if statement inside one of our other examples just so that you can see it all together. And we can combine statements as well. So we can use and, or, not, and we can use all sorts of things to combine statements and test for multiple conditions at the same time. And now I can't, for some reason, Jake keeps using the drinking age example, which is a bizarre example to use, but there you go. You can, do a quick test of conditions before you start drinking. Are you 18? Are you allowed to drink? So you can, basically, if true, then you'll evaluate the drinking age. Otherwise, you do something else. So let's have a look at the next thing that he covered in that pre-recorded lecture. It was the while loops. And what do we need while loops for? Well, we need while loops because C normally executes code in order, line by line. Starts, you enter in the main function always, and when you start off, then you'll go line by line. So if statements will allow us to turn things on or off the parts of code, but the while loops, they're going to allow us to have repetitive code. So it's going to allow us to repeat code over and over. So instead of having, copy and pasting something 7 or 8 times, you can actually have a loop which will allow us to repeat something until a certain condition has been met. So if some sort of condition is true, then we're going to do something over and over again, and we're going to update the condition each time. Otherwise, you're going to get into what's called an infinite loop, which is a bit of a problem because it means that you will never be able to exit and you'll be stuck there forever. And that will be that. Not going to be a very good program if you do that. Okay. So, would you like to actually, you know what, if Bree or John there, can you do a poll for me and just see if everyone wants to see an actual piece of code with an if statement or a while loop, a simple one, before we go to nested loops? If you want, I can do for you a little bit of an infinite loop as well, so you can see some magic. All right, let's do a while statement. And should we do an infinite while just so that you can see? Should we do an infinite? And just tell me if changed my position. I didn't even realize. Amazing. Okay, everyone wants to see an example. Fine, let's do an example. Okay, perfect. The first example I'm going to do, I think, is, should I do a real loop or an infinite loop? Well, both are real, but okay, now I need to think of an example. Let's just do a simple counting loop. And then we'll do oh no. Okay, wait for me. I've logged out. Okay, and we're back. Okay, and let me go to where all the code is. This is every time. I can't remember where I am, and I'm like, should I let us know? Okay, I'm where I want to be now. Okay, let's do while. Let's do a counting while, and then we'll do an infinite while as well. Okay, and let me make them available for you. Okay, perfect. All right, so let's do it. Okay, so this program will demonstrate a simple while loop. Yay, and it's week 2, and it is lecture 4. Okay, so the first thing is first is I'm going to include my standard input output so that I have access to things like printf and scanf. And then I'm going to start my int main so that we know where to enter the program. Okay, great. So what should be our while? Let's do just a simple counter. So steps in a while loop, basically you have 3 steps. One is you initialize the loop counter before the loop. Then what you're going to do is you're going to test for the condition in the loop. And the third thing that you should always remember to do, otherwise you're going to get an infinite loop, is that you need to update the loop counter. And this one happens inside the loop. Okay, this is the loop itself. And this one is before the loop. Okay. Okay. In exams, you'll be not asked to use specific loops. You can just use whatever loops the question requires, basically. Whatever you prefer, however your brain is solving that question, that's the loop that you use, right? Okay, and then someone's asked, okay, why do we use void inside the main? So, okay, so I don't know, it's hard because I don't know how much Jake has kind of talked about it, but basically you can do like this and you don't have to include the void, but there are some problems to that. So when you include void, it's basically partly it's good style because you are saying that you are not sending any inputs into the main function, because there are other things that you can have inside here, right, that are not just void. You can give something to main, which you will learn about in a few weeks, so I don't want to kind of name the things that, so they're called command line arguments. There's all sorts of things that you can give it. So instead you use main to kind of give it good style to say that there is nothing coming into the main, there are no inputs being given to this function, and that's that. So that's why we include void when there's nothing happening. Okay, so let's have a counter, and this is going to be our loop control variable. So that's going to be what we control the loop with, and I'm going to initialize it to 0 straight away. So this is me doing this first step. Then I'm going to test. Okay, so let's just count down to 10, right? So I'm going to check whether the counter is going to be less than 10, and I'm going to count downwards. So this is me doing the second thing, so testing for the condition in the loop. Okay, then I'm going to open. Okay, great. So I have now I've declared a variable called counter, and I've initialized it to 0. So I'm ready to start counting. Then I'm testing, am I counting down? Am I counting up? I'm counting up because I'm testing where the counter is less than 10. And then I'm going to count up to 10. And I'm going to stop when it counts up to 10. Why did I choose 10? I don't know. I pulled a number out of thin air, and it's a number I'm going to regret because 10 times feels like it's too many. So let's print something out just so that we can see it happening. And let's say we're going to say loop number, and I'm going to have a format specifier. Here we go. Okay, and we're going to fill it in with the variable counter. So we've got our placeholder format specify %d, and I'm going to say counter so we can see how it counts. And then the last thing that I want to do is I want to update the loop counter so that I am able to actually make some changes. Otherwise, you're going to get into an infinite loop. So I'm going to update the counter by increasing it by 1. I don't know if you've seen this yet, but what this is doing, counter plus plus, is it's doing counter is equal to counter plus 1. So it's a shorthand way, this plus plus, of writing counter is equals to counter plus 1. So I've updated the loop counter. So this is my step number 3 of running a loop. And then when I exit out of a loop, so what will the counter be when I exit out of the loop? Who wants to tell me what the counter will be? Any guesses? Let's just run it for a second. Okay, so lots of people think 9. So remember, when we're inside this while loop, when counter is 9, it will test the condition. Is 9 less than 10? Yes, it is, which means I'm going to do the loop one more time and I'm going to increase the counter to 10. So when I go back to check for the condition, what it's going to check is counter, which is going to be 10, is 10 less than 10? Well, this condition is not true. So I'm going to exit the loop, which means that when I exit the loop, my counter is going to be 10. Okay, and we can run through it as well. Like we can look at it. I'll do the code as though I'm the computer because sometimes that helps to understand. Okay, so let's compile our code, which no, that's not what the file is called, while count.c. Okay, so we've compiled okay, and now let's run it, and we should get a whole bunch of, oh gosh, well, I've killed the style here, very much so. How about we hit a new line here so that we can see what is happening? Otherwise, very difficult to actually see what's going on. So let's run it again. Okay, so now you'll see that we're going to count the number of loops, right? So it's number 0, number 1, number 2, number 3, blah, 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 blah. Now, it's going to go loop number 9 because loop started at 0. So actually 10 times it has looped through the code. And so when it exited the loop, the counter is going to be equal to 10. Yeah? So what we see here is basically if I'm the computer, what's happening is, wait, I have a pen that I want to use so much to write something. Just give me a second. I've lost my pen. That's very annoying. Oh, it's because yes, all good. I know why I've lost my pen. Okay, so basically what I have is when I go in here, I had a pen, now my pen is gone. Here it is. This is why I was trying to get my pen. Okay, I'm going to run through it just so that you can see what happens as though I am I'm the computer. If this is black, we're in big trouble. Let's make it yellow. Okay, so what happens here is we enter in here, okay? We enter into int main and we go over here. We declare a variable called counter, okay? And that variable counter, I'm going to regret this very much because why did I choose such a long-winded name? So we declare it and then we make it equal to 0, okay? So it's equal to 0 at this point, so on line 8. Then when we go to line 10, we're checking a condition. So counter right now is 0, which means it's going to check, is 0 less than 10? Yes, that condition is true, which means we're going to enter into the loop. And we're going to start with the first print loop. So it's going to say loop number blah, here we go, and my counter is equal to 0. So that's where it prints out this first statement here. Then what it does is increases counter by 1. So the next line of code, counter becomes 1, and it's going to go back and check again. So now it's checking whether counter is less than 10. So is 1 less than 10? Yes, it is. It's going to go into the loop. It's going to print the next loop. And then it's going to go down to line 14 and increase it by 1 again. So then it's going to be 2. So then the next condition it's going to check is it's going to check whether 2 is less than. So then it's going to check, is 2 less than 10? Yes, it is. It's going to enter back into the loop. It's going to do the next line over here, and then it's going to increase it by 1 again. And it's going to keep going, right? So let's keep going. Let's say this counter is now 9. So it's going to go here and it's going to check, is 9 less than 10? Yes, it is. So it's going to enter into the loop. It's going to print out this loop. So it's going to print out this line over here. And then it's going to increase the counter by 1 again. So it's going to go to 10. So when it goes back to this condition and checks, is 10 less than 10? That's not true, which means I'm not going to enter the loop and I'm going to go straight outside of the loop. So I'm going to come out of it. And at this point, counter is equal to 10. I don't really care about counter anymore. And that's it. I'm going to return 0 and exit out of this program. Okay, so that's just a simple loop. Now, what happens when I have an infinite loop is I'm going to keep going forever. Okay, let's get rid of all of this. So if I were to have an infinite loop, it always happens when I haven't updated my loop counter, okay? So what that means is this counter is not going to change. So counter is equal to 0. It hasn't changed, and each time it's just going to check, yep, 0 is less than 10. Yep, 0 is less than 10. Yep, 0 is less than 10. And it's going to keep going, 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 right? So let's have a look what's going to happen. So as you can see, I've commented out my loop counter. Okay, so there's nothing changing my loop counter. So when you see that you're doing your assignment, you're doing a lab, and you've got stuck in an infinite loop, usually it means you haven't updated the counter. Okay, bear with me. Let's compile it and let's run it. What's happening? Oh, who knows what's happening? I haven't saved it. See that little white dot? It means that I haven't actually saved my code, which means that it's still using my last. So now I've saved it. Now I've got an infinite loop. Everything is great. So I thought I was going insane. Okay, so I've compiled it, and now let's run it, and it's just going to keep going forever, right? Now, who knows how to exit out of this madness? How do I make it stop? Who knows how to make it stop if you do get stuck in an infinite loop? Yeah, well done. So if I press Control C, it will loop me out of here. And you can see that DCC also will throw you an error, which will show you where it's happened. And it just says it's been interrupted. That's where it's been interrupted. And it's because we haven't updated our loop control, okay? So we created an infinite loop, basically. I don't really need the other piece of code. Okay, I'll change it back so that the loop's there. Okay, how does everyone feel about while loops, simple while loops? Let's poll, do a little poll. How do we feel? Do we feel good so far? So again, in this course, I think week 1 is fantastic. Week 2 is fantastic. Week 3 starts getting a lot harder. Week 4 starts getting a lot harder. So try and get all the basics down pat, the foundational knowledge, so that you're able to increase the, the difficulty level straight away. All right, great. So we are ready to keep going then. Let's go back to here and we will talk about nested loops. Okay, so nested loops. Sometimes you need a loop inside a loop, right? You might want to do something within a particular, I'll show you some examples of a loop within a loop and why you would need it. But I always try and think of it as like, like an analog clock, right? I don't know if they're not like, they're still on the wall of every classroom, aren't they? In the cats' rooms, do they still have the clocks? Except none of them ever work, but they're still there. Are they still there? I think they're still there. I remember seeing them, but I don't even notice them anymore. So I always think of it as a clock, right? You've got the second hands in the center, and then out of that is the minutes, and then out of that is the hours. So you kind of have the one on the very inside is the seconds. So 60 seconds have to pass before each minute ticks over. Yeah. And then 60 minutes has to pass before each hour ticks over. So that's like a loop inside a loop, right? And my inside loop runs many, many times, whilst my outside loop runs less. It runs once for each time that, my inside loop finishes its movement. So basically what I'm saying is each time, so if you put a loop inside a loop, what it means is that each time a loop runs, it runs the other loop, and the inside loop ends up running a lot of times for kind of each one that an outside loop does. I should probably see what Jake wrote in his lecture notes. I do love to have a bit of a yap. So, okay, so he's kind of done that. He's kind of written what I've said. Why are nested loops useful? So when we have to print something, not just in like a one-dimensional space, so just like a line of something, so you know how to print out 1, 2, 3, 4, 5, but how do you do it in a grid pattern, right? So how do we do something that looks more like this? And so when we do something like this, it's good to kind of also break down the problem. And what I mean is, let me go back to the code and back to here, back to the code. So I am wearing glasses. Why can't I see very well? Okay. So I always like to, if we go to the grid, so we're going to do a while inside a while, and we're going to print out a grid. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now we already know how to print out just one line. Okay. So let's do our code to just print out one line, and then we can start thinking about how we would do it for a grid where it goes downwards as well. Okay, so first things first, let's include our standard input output so that we have our printf, and let's go into our main. All right. And I saw someone ask, what does return 0 mean? It's basically, there is a bit of a standard way, 0 and 1's returning. 0 means that the program has run successfully with no errors. Usually what it means, it can, right? Just as a standard sort of style. But you will learn more about it when you go to learn about functions, which I think is next week, which is really exciting. Functions really are amazing. So that will be, you'll have a good time with that. Okay, where was I? Oh yes, my gosh, so easily distracted. Okay, we're doing a while loop and we're just printing out one line. Okay, we're going to print out 1, 2, 3, 4, 5. And so we know that that means we're going to potentially have a counter, right? And we're going to increase it by 1 each time so that we don't just print out 1, 2, 3, 4. You know, we don't want to just print F and then 1, 2, 3, 4, 5. We want to make the program full of variables so that it is applicable for any number of things, right? Not just a square that's got 1 to 5. Oh, good. Just in case we wanted Adobe Acrobat to open randomly. Fantastic. Okay, so let's do it. Let's just do a little, yeah. Okay, so the first thing I'm going to do, I'm going to comment through. So the way I'm commenting code is I'm writing a lot of comments. You don't need to do that many comments. It's so that when you go back to this code, especially in the beginning, you know what we have done. So I'm going to initialize a loop control variable. And I'm going to call it count, just so that if I run through the code, I don't have to write counter. That's really all. Okay, and we're going to go, should we scan in the size of the square? Let's scan in the size of a square. How does that sound? I don't know how much you've done, so I'm just going to go crazy. Just tell me if you haven't done it yet. Okay, so what I'm going to do is I'm going to have another one called size, and I'm going to ask the user to tell me what is the size of the square you want to print. And then I'm going to scan in. So remember, when I'm scanfing, I'm going to take in an int. So it's going to be %d. And remember to put the ampersand down when you're scanning into the variable size. So it tells it to please scan it into the variable size and kind of go with it. You can int count to anything, right? It's just easier and logically makes more sense if we start counting from 0. And in computer science, you'll learn about arrays soon. Arrays start indexing at 0, so we very much always start counting from 0. Because we have to be special in computer science. We can't just be like everyone else and start counting at 1. Okay, so now we apparently have a size of something, and we also have a variable that we might use to control it, although we might not need it. Let's just work with it. I'm really making this part up, so yep, let's just go with it. Okay, so I want to be having a while loop now because I want to print out 1, 2, 3, 4, 5 in a line. So what I want to be doing here is I want to test the condition of the size. So I might not even need this for a second. So this is initializing the loop control. We're going to use a loop control that we haven't hard coded, but that a user has given us. Okay. All right. Excellent. So we're going to test for that condition. So we're going to test. So presumably, if a user is going to enter the size of a square that they want to print, they're going to give us a number like 5, for example. Just, again, number out of thin air. And that means that we're going to want to count downwards, right? Because we want to print it out 5 times, and we're going to have to subtract each time. So we're going to check whether, well, this is not going to work, is it? We do need our control variable. No, we don't. I'm here. Today it's been a very long weekend. I'm going to check whether size is greater than 0. Okay? Because presumably if I'm subtracting from size, then I'm going to get to 0 sometimes. So I'm going to test the condition of the size. So that's my second part of a while loop. And my third part of a while loop is I'm going to update the loop control variable. And in my case, I'm going to not size plus plus, I'm going to size minus minus. And what that means is size is equal to size minus 1. That's exactly the same. So what I've done is, let's say someone puts in 5 here, then it's going to check, is 5 greater than 0? Yes, it is. I'm going to enter the loop, and I'm going to say when I complete some action, then I'm going to reduce it by 1. Okay, and then print out here, we're going to print out the number, so %d and a space, and it's going to be our size variable. Okay, fantastic. Okay, and then so this presumably will do something. So let's see what it does so that we know what we need to add or what our program still needs to do so that we're not, now can you see the grid? Yes, you can. Okay, good. Let's compile it. And let's run it to see what is happening. Okay, so what's the size of the square you want to print? So it's declared in size, hasn't initialized it, but now it's gone into the printf statement. So my printf statement is now, I gesticulate a lot, and obviously my computer's now annoyed at that. Okay, so what's the size of the square you want to print? We're on line 23. And let's do, what should we do? 5. Let's do 5. Why not? So I'm going to put in 5 and enter. And what that means is I have now scanned in 5. Size is equal to 5. And I've gone into my while loop. So now I'm printing out 5, 4, 3, 2, 1. I'm going to go a backwards loop. Oh, well, we've gone strong, right? Haven't we? We'll just go with it, and then we're gonna turn it around. Don't worry. So we're gonna do 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. My God, I really need to stop doing that when I just make stuff up on the spot. Great, we've got one line. Now, if I wanted to have a new line at the end of this row, okay, where do you think I will put printf a new line? Would it be outside of the while loop or inside of the while loop? Would I put it here on line 29 or would I put it over here on line 33? What do you guys think? If I wanted to have a new line at the end of this row, just one whole row. Okay, right now we've got 2 insides, 1 outside. More inside. Another inside. Lots of inside votes. A few more outsides. Insides. Ah! Okay, if I put it in here, okay, like you suggest, what's going to happen is that this... Oh, well, I'll just wait for the poll. Let's see where it's going. I'll give you a minute to answer. Oh, 20 votes only. Oh, neck and neck. It's a bit of excitement. No one's convinced. Where should it go? Do you know what the best way to learn where it should go? You should just try it everywhere afterwards. Just break this code, try it inside, try it outside, try it in printf so that you can see what it does. It's the best way to learn. All right, I'm going to show you where it should go. So if I put it inside the printf statement, okay, what it means is that every time we enter the while loop, we're going to have a new line, okay? So it's not really going to work for us, but let's have a look what it actually does. So if I run it and I'll go 5 again, it's going to put it after every single number, okay? So we know this is not the place for it, and the reason for it is that it's going to print this new line every time it enters the loop, right? After every single variable. Now, if I just decide to put it in here, okay, it's going to do something, it's going to do something very similar. Again, because it's going to print a new line after every single time that before I exit out of the loop. So it's going to keep printing that new line every time that the loop is done, okay? So where I want to print this new line is outside of my while loop, okay? Because what that allows me to do is I really want it to be right at the end after the whole row is done. So I'm going to place it over here because I only want it printed once. I want it at the end of every row and not at each iteration of the loop, okay? So if I'm going to compile again and run again, now it's going to print it out and then new line at the end of the loop. Okay, excellent. And you probably can't see anything because it's all the way at the bottom of the screen. So let me clear the screen. So how fantastic. Let me just change this so this is not confusing, and then we'll do it the opposite way. So 5, 3, 2, 1. So we've got it doing one part of this question, right? We have it doing one line, exactly what we wanted to do. But now we want to make it a square. We want it to just go again. Actually, you know what? Let's now, so we've got it printing out 5, 4, 3, 2, 1. I want it to print out 1, 2, 3, 4, 5. How do you think I can do that? What do you think I could do in this piece of code to make it print out 1, 2, 3, 4, 5 instead of 5, 4, 3, 2, 1? What do you think is the fast way to do it? Okay, so someone is saying 6 minus size. Yes, partly, but I don't want to hard code anything. Yeah? Yeah, I can have another variable that I can start counting at a smaller number, and I can then, my condition could be where I'm checking that count is, that's greater than, less than size. I don't know how old I am, but I'm still doing, you know, the alligator eats the bigger number. So I'm going to check that count is less than size. And over here, instead of changing the size, what I'm going to do is I'm going to increase the count. And what that will do is it will move up one variable. So I'm printing out the opposite way, okay? So then what it looks like, if I run it again, compile it and run it, and I'll go 5, And now I've got, and do we know why that's happening? Okay, so there is a mistake. Do we know why it's printing out 5, 5, 5, 5? I've lost count, 5. Do we know why this is happening? How will we troubleshoot this? How would we debug this issue? And this is a logical issue because it's not stopping the compilation of the code. So what do we reckon we would do? Yes, well done. We're printing the size over here and not the count. So it's doing exactly what I told it to do. It's just that I changed one thing and I didn't change the other. So I want to be printing out the count. So let's compile again and let's run again, and 5, and we've got 0, 1, 2, 3, 4, which is still not what I want. Okay, I want it to be 1, 2, 3, 4, 5. So, but I'm getting closer now. I'm not printing out lots of 5s. So how would I make it go 1, 2, 3, 4, 5? What do we reckon? Yeah, well done. So I would initialize my count to start at 1 as opposed to starting at 0 because I want it to go from 1. Excellent. Well done, everyone. Okay, so let's compile it and let's run it and let's go 5s. And of course, we're going to have a problem here. And that's because, yeah, so a few people are saying straight away the double thing. I'm going to need to change the condition as well. Yeah, so it can't just be less than, it has to be less than or equal to, because I wanted to print the 5. So when count is equal to 5, I still want it to be printed. Okay, great. So we've debugged a few logical problems and we've got it printing out one line. So now we want to be able for it to be a grid, okay? So we've got one loop, and what it means now is we're going to put in a second loop inside the first loop. Okay, so this is one loop, and we're going to nest another loop in here now. Okay. Okay. Just deciding how much to, should I change it to row and columns? Should I change it to I's and J's to make it easier to understand now? Okay, so what it means right now, we have one loop control variable because we have one loop. What I'm going to do is I'm going to do 2 loops, okay? And that means I'm going to have a loop inside a loop, which means I need 2 loop control variables. So I'm going to control the 2 loops. So instead of this count, I'm going to just comment it out so you can see it later. I'm going to have an int I, and I'm going to have an int j. So, okay, j is going to be my inside loop, okay? And I'm going to make it exactly the same as int count, and I'm going to initialize it to 1, and then we'll see what we need to do with int I in a second. Okay, great. So now for my outer loop, remember I'll do my outer loop first and I'll use i's to count off the outer loop. So whilst I is less than or equal to size, no, I'm going to keep that so that we can see what mistakes it makes, okay? And then this loop is going to be my j, and j, because it's a square, we're going to go with size as well. Okay, great. And something is going to happen in here. So I've got one loop here and one loop here. I'm just going to comment this out for a second so that we can see what's going on. Okay, now the way I like to structure loops is I'm going to be doing something here. So I'm going to increase my j here, and that means I'm not going to forget to update the loop. And my I is sitting outside. So this is the last bracket to my I. So I want to be able to remember to increase my I as well. So right now I've got all the conditions of a loop. So I have declared and initialized a loop control variable for both my loops. There's an I and a j. I've tested for both of them, and I've also updated the variables where it's relevant to do it. Okay, now I need to do some printing. So remember what happens. The inside loop is the one that runs many times. So where do you think I will do my printout to print out my 1, 2, 3, 4, 5 in a line? Will I do it on the inside loop or will I do it on the outside loop? What do we think? Don't worry, a small break is coming after I break you. Outside, outside, inside, inside, inside loop, inside loop, inside loop. A few outsides, a few insides. So because I want it to be printing out many times, okay, it's going to go on the inside, okay, which means that I'm printing out the J over here. So I'm going to start the J at 1 and I'm going to print it out, and it's going to keep printing out 1, 2, 3, 4, 5. Now remember, we printed out the new line at the end of our loop, right? So the end of that loop here, it's going to be 1 row. So I'm going to move my print new line statement to the just outside the just outside the inside loop. Oh my God, as I'm speaking, I'm just realizing how confusing the inside, outside, just slightly outside, etc., etc. Okay, so this will give me something. It's not quite right, okay, but we're going to run it because we want to see. Don't worry about running code and there's something missing. I've got a bracket, that's an extra. Aha. There we go. I was missing a bracket. I could see it. Okay, so don't be worried about compiling code just to see what it's doing, right? So let's compile it to see what it's doing now, and let's run it. Who thinks it's going to be perfect? It won't be perfect. Let's do 5 again. And we have some sort of mess, right? A lot happening. It's printed out 1, 2, 3, 4, 5 in a line. Why is it doing it? Don't know. Well, someone knows. I can see someone knows because they're saying we need to reset the J. I agree. Also, this new line, this bracket is now in the wrong place because it's sitting. I really wanted it to do this. Okay, and then let's see why we need to reset the J. Okay, so it's doing this 1, 2, 3, 4, 5. Then it's giving us a lot of spaces and it's not printing out anything else again. Okay, now someone has said that we need to reset the J, and that is correct. We do need to reset the J. So let's see why we need to do that. I'm going to run through the code and I'm going to do it like as though I'm the computer calculating it so that you can see why we would need to reset the J. All right, does that sound good? Even if it doesn't, it's happening because I think this is going to be the maybe, hopefully, where it makes sense for those that are just a little bit lost right now. All right, I go into the main because I'm the computer and I start working through the code. I skip everything that's comments because I'm a computer and I don't care about comments. Those are for people. I declare and initialize a variable. The first variable that I declare is I. And so I declare I and I initialize it to 0. Great. Then I declare J and I initialize it to 1. Fantastic. Then I declare something called size. I'm just not happy. I just love my variables. Okay, and I don't initialize it. It's just been declared. Okay, great. Then I go here and I print out what is the size of the square you want to print. And let's say over here I enter 5 on terminal, which I have been doing so far. You know what? Let's do 3 because it's going to get really old trying to do 5 with this pen. So let's say I'm going to enter 3 in here, which means that size is now going to get initialized to the value 3. I'm going to then go into and test for a loop condition. My I right now is 0 and my size right now is 3. So I'm testing whether 0 is less than or equal to 3. This is true. Okay, so it's true, which means that I'm going to enter into this loop. And when I enter into this loop, I'm going to go in here and I'm going to test whether j is less than or equal to size. So j is 1, size is 3. Is j less than or equal to 3? Yes, it is. It is true, which means I'm going to enter into my next loop because it's true. I'm going to enter in here and I'm going to print out %dj. So j is 1, which means that I'm going to print out this one over here and a space. Great. Then I'm going to increase j by 1. So j is going to become 2. And I'm going to go back to the loop and I'm going to test whether 2 is less than or equal to 3. Yes, it is. It's still true. So I'm going to enter in here and I'm going to print out. So I've printed out 1. I'm going to print out 2 now and a space. And then I'm going to increase j by 1 again. So now j is 3. So I'm going to go back here and I'm going to test again. Is 3 less than or equal to 3? Yes, it is. It's still true. So I'm going to enter in here and I'm going to print out the 3 and a little space. And I'm going to increase j by 1. So j is now 4. Excellent. I'm going to go back out. I'm going to check, is 4 less than or equal to 3? That's now false, which means I'm going to get to break out of the loop and I'm going to go to this line here. And so that what that means is I enter a new line, which means I'm now on this line. And I'm going to increase I by 1. Okay, so I is going to go to 1 and I'm going to go to my outside loop and I'm going to test it again. So is 1 less than or equal to 3? Yes, it's true. I'm going to enter in here and I'm going to test my j. Okay, and so when I'm testing my j, I'm going to test whether j is less than or equal. Now j is 4 right now, which means that when I go in here, what I'm testing is 4 is less than or equal to 3, which is false, which means I'm going to skip over this. I'm going to print another new line, which is what you saw here. And then I'm going to increase I again. I'm going to increase I by 1 more. So what's happening here is that I never enter the second loop after that first time, okay? And the reason I don't is because my j variable is still sitting at whatever it was in the last loop. So because I always want to be starting this row anew, what I need to do is I need to reset that internal variable back to whatever it was at the start. And that will allow me to constantly enter that internal loop, the inside loop, multiple times. Okay, how's everyone feeling about that? Does that kind of make sense? Hey, Bree, can you run a poll to see where we're at? Do we make sense? Do we not make sense? Thank you, Bree. Okay, so what I'll do is I'm going to reset it back to 1. So then every time I increase my I, so every time I go to a new line, then I'll start my j counting again. Okay, let's see what happens. Okay, so let's run it. And let's see what we have. Okay, so now I've got a grid, but the grid has 1, 2, 3, 4, 5, 6. Okay, so it's got 6 instead of 5. I want it to be a square. So there's a logical issue somewhere. So if I was to debug, then what is wrong? If I were just seeing and I'm just thinking, oh, I've had enough of this. What have I done wrong? Yeah, so my I is going to count, because I'm here testing for I is less than or equal to size, it's going to count when I is equal to 5. It's still going to go into that loop, so it's going to do an extra round. So if I want to keep the I as 0, then what I would do is I would get rid of the equal sign, or what I can do is I can set it to 1 and then keep the equal sign, because it's going to give me the same end count, right? So if I were to save that and now run it, it should give me the perfect grid. Ta-da! So now giving me the 5 by 5 grid. That's just magical. Okay, so after this lecture, I also want you to be able to like go and try and break this code a little bit, do a whole bunch of different things in it that might, you know, change it up, see what is making sense and what's not. And what I find very useful, well, when I was learning to code, is get a piece of paper and a pen. Pretend you're the computer, especially for these smaller programs. Run through it as though you are the computer performing the operations, right? And then the mistakes will become very obvious straight away where you've made a little logic mistake. Okay, I think it's 12 o'clock, so it's good time to have a 7-minute break, 5 to 7-minute break. Very precise. And then we will keep going after that because we've got a whole bunch more things to cover. Just in case you thought that you were done for today, you're not. So let's do a 5-minute break and then we will come back after that. All right, we're back. Hope you enjoyed your 5 minutes. We're back and we're going to print out a half pyramid. So super exciting stuff. Okay, so far we have a perfect grid. So now we want to have a half pyramid. We don't want to have the perfect grid. We actually just want to have 1, then 1, 2, then 1, 2, 3, 1, 2, 3, 4. So that we don't have to do the scanf thing again, what I'm going to do, well, first of all, I'm going to hash include our standard input output. And then what I'm going to do, just to make it easier for us for this problem, we've done our scanf. So I'm going to hash define size and I'm going to make it 5, okay? So what that's doing is basically, I'm not having a user enter like we did in the grid. We had our scanf, which means that we can change the different sizes. I could have had 7, 8, 9, and it would have worked for all of them, right? This time, we're just going to hard code just to see how it works, right? And what we're doing. Okay, so let's go to int main again. Nope. Let's do it. Okay, so if we were to do this problem as though we're doing a grid, right? And we know how to do a grid, we would have had our usual int I is equal to, well, let's just start them with 1. Okay, then we would have had our first while loop, and the first while loop would have checked whether I is greater than or equal to size. And size is hash defined, which is why it is in capital letters. Okay, and then exactly how we did before, we had the second loop control variable, j, we reset it each time that it entered, each time that we would need, that we completed the outer loop. So each time the inside loop has run enough times and the outer loop moved by 1, we would reset the inside variable back to the start. Okay, and if we were just doing the grid, this would also be j is equal to size. Okay, and we will see what we need to change in a second. And I'm going to print out %d, and I'm going to print out j. My God, I'm really struggling with my typing today. Okay, and I'm going to increase my 1 variable, and then my I has to be increased in here as my other loop control variable. And I also had a new line. Okay, so this is doing that perfect. Don't know what's going on. Struggle town, that's what's going on. Okay, so this is my perfect little grid. Okay, so if I run this now, except it's not what I want, but it's a grid. Okay, so let's see, and then we will talk about what we need to do to change it. Okay, so if we do pyramid.c, pyramid. And let's run it. Great. So it's printing out exactly the same because we literally just wrote exactly the same thing. But now we don't want to do that. We want it to look like this. The first time we only wanted to print 1. Okay. So that means that we need to control our inside loop in a different way. Yeah. So our outside loop controls how many of these rows there are. And there are 5 rows. And that's the same as our size. So that makes sense. So that means the outside loop control is working well because there's going to be 5 different columns here as we type. But the ones that are going the inside loop, so the ones that are actually printing out what's happening, they are doing too much each time. And we want it to be the first time to just print 1. So that means that our control here has to be somewhat different. What do you think I can use as my control instead of size to make it print a half pyramid instead? So to make it print just 1 to start with, and then just 2, and so on and so forth. So note here that in row 1, it prints out 1. In row 2, it prints out 1, 2. In row 3, it prints out 1, 2, 3. In row 4, it prints out 1, 2, 3, 4, and so on and so forth. So just when you thought year 7 algebra patterns is gone, No, you're back right there in that nightmare. You are now looking at those stupid tables and patterns. What do we reckon? What do we think? So this size is not going to be the way to control it, but I'm going to control it because the row number matches how many things I want to print out. Yeah? So I can control it with my outside variable. What do we think? How's everyone feeling? It's gone very silent all of a sudden. So that's my outside loop control. So when it's 1, it'll print out 1. Then when it increases to 2, it'll go up to 2, so on and so forth. So let's try it, and then we can run through the code as though we're the computer. And then we'll move on from the loops. How magical! It's worked. Who has no idea what is happening right now? It feels like it because it's so quiet. Let's just quickly go through it. Okay, so we enter into the main, okay? And then we go to our first one. So we declare and initialize our variable. So the first variable has been declared and we initialize it to 1. And then we go into a while loop here. So I is 1, size is 5. Remember, we do a find and replace when we have a hash define, and I have it hash defined here. So when it's, and then I go to my next line. So this is true. 1 is less than or equal to 5. So because it's true, I'm going to enter into this loop and I'm going to declare and initialize the next variable, and it's going to be j, and I'm going to initialize it to 1. And then I'm going to check what's going on here. I'm now checking whether j, which is 1, is less than or equal to I, which is 1. What that's telling me is I'm on the first row and I only want the 1 printed. So when I print it out, I'm going to print out the j, so I'll print out the 1, and then I'll move on and I'll increase j by 1. So j will become 2. And when I go back to check my condition, 2 is not less than or equal to 1, which means that this is false, and I'm going to exit out of the loop. I'm going to print a new line, which means I'm going to go down to here, and I'm going to increase my I. So my I is now equal to 2, and I'm going to go back and check my outside loop. So now I'm going to check, is 2 less than or equal to 5? Yes, that's true. I enter into this loop. I move j back to 1. So j goes back to 1. And I check again. So is 1, so my new thing that I'm checking, is 1 less than or equal to I, and I is equal to 2. So that's true. I go in here and I print out j. So that's 1. Excellent. I'll increase j by 1. So now it becomes 2. And I'll go back and check again. Is 2 less than or equal to 2? Yes, it is. So I go into this inside loop and I print it out again. So now it's going to be equal to 2. And then I increase it again to 3. I check the loop again. Is 3 less than or equal to 2? No, that's false, which means I exit out of it. I print a new line and I increase I by 1. So it goes to 3. And I check it over here. Is 3 less than or equal to 5? Yes, it is true. So I enter into this loop. My j is reset to 1. And in fact, j is killed off. Well, actually, just I'll let you do it in functions. So 1, and then I'll check again. So is 1 less than or equal to I is now 3. So is it less than or equal to 3? Yes, it is. I enter in here and I print out my 1. I increase j by 1. So it now becomes 2. I'll check again. Is 2 less than or equal to 3? Yes, it is. I'll go in here again. I'll print out the 2. I'll j++. So then I'll go, now it's equal to 3. Is 3 less than or equal to 3? Yes, it is. So I'll go into the loop again and I'll print out a 3 now. I'll increase it by 1, which means it will go to 4. And when I check the condition is 4 less than or equal to 3, it's going to be false, which means I exit out, I print a new line, and I increase I by 1. So I is going to go to 4, and so on and so forth, right? So that's how that's going to work, and it's going to give me a perfect half pyramid. Okay, Bree, can we do a poll whether that makes sense? How are we feeling about the half pyramid? And also, when you are going home and obviously practicing for hours your loops, and it's a really good idea when you're doing that at home if you just put a little printf and print out what the condition is when you exit out of the loop, because it's really important to understand what the condition is once you've exited the loop. It really allows you to understand loops so much better when you understand what is happening when you break out of the loop. Okay, so what's the point of defining size? Why can't we just write I is less than or equal to 5? The reason we don't want to do that is because we don't want to have any magic numbers in our code, right? So think about it this way. The code that you're writing is actually for human eyes to read, okay? So when we run DCC and we compile it, it creates the program that the computer can read. So the code that you write is for humans. And when I'm looking at thousands of lines of code and I see something that says I is less than or equal to 5, I actually have no idea what that 5 means. Whereas if I've hash defined something called size and made it equal to 5, it tells me straight away that the name of it tells me straight away what it might be. So it is a matter of style, making sure that you don't have any of these magic numbers littered through your code, because remember that a human has to come in and be able to read and understand your code. And that's very important. That's really the point. Okay. Okay, I'm pleased. It makes a lot and a little sense. So for those that it makes a little sense, make sure to go home and do a single loop again and then do a double loop again. Remember, you've got to spend a few hours just trying different things, put things, outside the loop, inside the loop, change the loop condition variables, but just make sure that you always know your 3 steps in a loop is initialize something that you're controlling the loop with, test for it, and then also update that variable as well. But try it at home. Try breaking each of those points and see what it does. It's really good for learning. Okay, fantastic. Let's move on to the next thing. And the next thing you're going to learn about is custom data types. Woo! A little bit of excitement with some custom data. Oh, that's really unhelpful where my camera is, isn't it? I don't know where to put it to make it more helpful. Oh, there we go. Okay, so far in the last week and a half, what you've done is you've used ints, you've used chars, you've used doubles, and all of those things are built in C data types, right? And sometimes you've got things that you want to do, right? And none of them fit perfectly into this, into this box of it's an int, it's a char, it's a double. All of those things, if you have an int, that's it. All it stores is one int. If you have a char, all it stores is one character. So they all store only a single item of that type. But that's not always how real world problems work. Sometimes we want to be doing things that require us to group items together. We might want to group, a char with an int together and they form like a greater something, right? So what that means is we want to have a data type that allows us to group things together. So for example, oh, what a beautiful example. My age is not 20. Wish it was sometimes. No, actually, I wish it wasn't. No, 20 is a hard time. Maybe 25. Okay, so it's grouping my age. It's grouping an initial of my character and also what year in I am at UNSW. So those things all belong potentially to one student. Okay, and if all of those things belong to one student, we really want them to be grouped together as one thing. And that means that we want to not have 3 separate variables, but we want to have one variable that is able to store these 3 different things together. And I guess you know what I'm going to say, but that is available to you, okay? And you have this thing in C called a structure. And that is a type of variable or the type of data type that allows you to store a collection of different types together that are related to each other. I mean, they could be unrelated, but then why would you have a struct? You really don't need it then. So you are able to store things together that are different data types all together in this one custom type that you've made. Yeah, this beautiful struct, and you can declare it. Okay, so Jake wants to be a student. Well, that time is gone, Jake. You are no longer a student. So basically what you do is you can, let's say you've got a UNSW student struct. What you would do is you would use the keyword struct, and you declare your struct outside of your main, okay? Not in your main, but outside of it. So when you declare it, you will have the same way that you declare a normal variable, okay? In that you will say what kind of variable it is, so the data type, and that's a struct, okay? And then the same as before, you give it a name. So the name here is UNSW student. So the same as when you do int count, right? It's the same thing. Int is telling us what data type I want, and then count is the name of that variable. So the same thing here. You're saying struct is the type that I want, and then the name of it is UNSW student. You then use these curly braces, okay? And you should have a semicolon at the end of this curly brace, and there's a reason for it, and that's because you can have other things happening beyond that curly brace that you then finish with a semicolon, not a curly. And then inside it, you will say what are the different data types that you want to kind of group together. Okay, so in this case, you want your age, it's an int, you want an int year number, and a double wham. So 3 things that kind of go together. You can have a char, you can have more than 3 things, right? The world's your oyster. Amazing. And then when you want to use it in code, okay, in your main, what you would do is you have to say, okay, I want to use a struct, data type struct, and it's UNSW student. And that's so that it knows, because you might have multiple structs defined in your code. It knows which one it is. And then you say, all right, and then my variable name is Jake. And that's how you use it within the code. So let's see it in action, because sometimes it doesn't make any sense when I describe it, when I just describe it in my language, makes good sense. Yeah, very good sense. Nailing English today. And that's probably why I did computing. Okay, let's have I need to switch over, otherwise you can't see what I'm doing. Things are going so well. Here we are, we're back. Okay, and let's switch over. Let me do a new piece of code, and that piece of code is actually, can you see that code that I've done there? No, you can't. Let me make it available to you. Let me make that pyramid available to you. And now let's do our struct.c. Okay, perfect. Are we going to do a struct student? Ugh, I hate it. Okay, I'm going to do a struct student. We can do other ones as well. Okay, and it is week 2 and it is lecture 4. Amazing. So the way you do it is, first of all, I'm going to include, as usual, my STD, my standard input output studio. And the first thing I'm going to do is I'm going to declare a struct, or even a struct that I will use. And it's going to happen outside of the main function, okay? Because that means it's available everywhere. And again, you will see how this is relevant next week when you do functions. Okay, so my struct, I'm going to use the keyword struct, and then I'm going to give it a little title, and it's going to be called student. And remember, when I'm declaring it, I have to finish it with a semicolon. Important here. Okay, just like you would declare your normal int count is equal to 7, and then you put a semicolon there as well, kind of like that. So I'm declaring my struct, oh my god, strust, Do you trust this struct? Okay. Okay, fantastic. Student, and I'm going to have a few things. Let's have an int age, and we'll have an int year number. I'm just going to use the same ones as Jake, but I'm going to add a char just because, you know, char, name, and one more thing, just so that we can see that it can have whatever you want in it, and it's going to be a wham. Okay. So I've got 4 things inside my struct that I'm going to pile together: int age, year number, the name, and the wham. Okay, now that I've declared the struct, I'm going to have a main function, okay? And inside this main function, I'm going to declare a variable of type struct student, okay? Now, if Jake wants to be a student, let's make him a student. So struct student, and Jake is going to be, so this is my variable name, and I'm saying that I want my data type struct, and it's of type student. So this one over here. So that means that Jake now has, this is going to be so weird. Jake now has inside of him these 4 different data types, okay? So we've declared that we want to use a type of struct student, which means that we gave it a variable name. And now we want to initialize Jake, which is very exciting stuff. Okay. Now, I can't just say Jake is equal to 5, right? The way I've been doing int count is equal to 5. I can't do that. And the reason for that is, what does it mean if Jake is equal to 5? There is age, there is year number, there's char name, there's double wham. Where is the 5 coming from, and where is it going to? It doesn't make sense because there are multiple different things that I can assign that 5 to, because there's actually 4 different members of that struct. Okay, so when I'm initializing a struct, I have to initialize the individual members of that struct. Okay, I can't just be, it's not magical. And to do it, what you would do, how would you say, I want to have the age? Okay, so the way to access a member of the struct is you use a little dot. So what I've said now is I want variable name Jake, and I've put a dot to tell me which of these members I want. So I'm going to start with age. So I'm going to say Jake.age, which means please take me to the first to age, and I'm going to store something in it. And Jake is older than 5. Let's go to my magical age of 20. I'm not 25, but let's go to a magical age of 25. Okay, great. Now I want to initialize year number. So I'm going to do the same thing. I'm going to use that dot, and I'm going to say access the year number struct, and Jake is going to be in 3rd year of university. Okay, great. Now I want to assign a name. Now that name is a char, which means I put it in single quotation marks because it's a char, and I'm going to give it a little j as the wonderful thing that is initialized to. And finally, Jake.wham. So now going to initialize the wham. Okay, Jake.wham. Oh, should he be a good student or a bad student? Has he been having a good 3 years at uni or a bad 3 years at uni? Has he been studying hard or not so hard? 100? My goodness. That's not fun. Oh, he's been a good student. 32. Well, that's... Oh, he seems to be failing out of uni. Let's give him a little... Oh, 100. He is nice. He is nice. But I want to give it a double. Yeah, he's a good student. He's always talking about the... Let's give him 95.5. We've got to give him something to work towards. He's got to get back those 4.5 marks. Claw his way to 100. Okay. So, 99.99 and 32.22. They're just polar opposites. And I went with some sort of happy... Not even happy in the medium. 95.5. We'll give him something to work towards. Okay, excellent. So I've initialized this struct, and now I'm going to print out these values, okay, just so that you can see that they've gone in there. And then we're going to try and change a few of the things just to see that you can do that and to manipulate things. So I'm going to print stuff out. I'm going to printf, and I'm going to say, let's say J is, he's going to be 25, is in something year of uni, and has a WAM of LF. Amazing. So I've got a few things here, haven't I? Now what's going to happen is I'm going to run out of room over there, I think. Did Jake say he's 30? Did he? It's true, he didn't lie. Okay. So what have we got? Okay, we've got our %C first. Okay, so we've got our name first. So the same way that I was initializing things, I'm going to also access them. So the first thing I'm accessing is the variable type Jake. Okay, that's not what I wanted. My computer's having a mind of its own. And I'm going to access .name, okay? The difference between them is %C is the format specifier for character. So %C is the character format specifier, which means I'm printing out a character. Printing out a character. Then I have %D, and %D is an int format specifier. It means I'm printing out a digit, so an int type. And then my %LF is a long float or a decimal number. So format specifier, and I'm printing out a decimal. Okay, great. So I've got name, then his age. So I'm going to say Jake.age. And then the next variable I've placeholdered is in what year uni he's in. So the next one is going to be Jake.year number. And then the last one is the WAM. So Jake.WAM. Okay. Let's save it. Okay, and let's run it. And Jay is 25, is in 3 year of uni, obviously English, not a strong point today, and has a WAM of 95.5, so many zeros, so many zeros. Now that is really quite awful. Now who remembers, well, I don't know if you've actually done it, but I'm going to pretend that you did. So who remembers if you have done a way to get rid of some of those zeros and to limit the number of decimal points that you're printing out? Does anyone remember how to make this LF print out a certain number of... Stop, dictionary, stop. So close, you're very close. Yes, well done. So you put in the beginning how many decimal points you want. So what do we want? 1 decimal place, 2 decimal places? What's our vibes? Okay, 2 decimal places. Oh. Okay, so all right, amazing. So we have our beautiful 2 decimal places, long float, or decimal printout. Okay, amazing. Now, let's say that I want to age Jake a little bit. Let's age him by 5 more years, okay? So that means that I want to add 5 to the age member of the struct, okay? So usually if I want to add 5 to something, I'd say count is equal to count plus 5. Similarly, for a struct, we literally do the same thing, except that we're doing it to a particular member. So with a struct, it's never to the full thing because a struct is made up of many things. So Jake.age is equal to Jake.age plus 5. Okay, so we're going to age him. And then we're going to print out, woohoo, Jake is now %D. And let's check that it's updated it. So let's compile it again. And let's run it. And Jake is now 30 because if we add 5 to 25, we get 30. So similarly for the struct, to do something, we do exactly the same. We just do it to a particular member of the struct. How is everyone feeling about structs so far? Let me show you, for example, okay, you can also, yeah, so the struct is declared. It's actually not a declaration, sorry. I should really use English. This is called a definition. So first you define a struct, then you declare the struct inside the main. It's my fault. I shouldn't have said. So you define it. It should be define a struct outside of the main. You declare a variable of type struct student inside the main, and then you initialize it inside the main. Okay. How are we feeling? Oh, it's still on the pyramid. Can someone, Bree, sorry, can you do a poll for structs? How do we feel about structs? Are we in love with them? Are we not in love with them? We're feeling them a little bit. We are. Let's do coordinates as well, whilst that poll is running. Well, whilst it's being set up. Oh, what a great question. Can you have structs within structs? You absolutely can. Yes. They're amazing. You can have structs within structs within structs. Yes, you can have structs within structs, and you'll see it being used in the assignment. You can have anything inside that struct, basically. Well, yeah. And then you will need, you know, dot, dot. Yeah. Well done. Okay, I'm going to use coordinates because coordinates is a really obvious way why we would ever need to have a struct. Like if you've never kind of seen a struct or seen problems that need solving, coordinates are, you can't have just an x coordinate and a y coordinate. Let's say I have a bunch of let's say I have a bunch of points. So let's pretend, oh my god, I'm going to run out of time for enums. Let's demo some structs. Yay. Okay, let's say I have 4 coordinates, okay? Now each coordinate has an x and a y, yeah? We know that, that's just basic points, right? So that means I have x1, x2. So if I have a main, and I want to do 4 coordinate points, okay? I'm going to be there going, okay, int x1, int y1, int x2, int y2, int x3, int y3, int x4, int y4, right? Bit messy, isn't it? Quite messy, considering that these two are related to each other, these two are related to each other, these two and these two. I really have 4 points, but right now I have 8 variables. So it's really not very nice way to do it, to be declaring it like that. So what I can do is I can define a struct for each coordinate point, okay? So if I'm defining a struct, and I'm going to call it coordinate, and the struct is going to have 2 things in it. It's going to have an int x and an int y. So each coordinate point has an x coordinate and a y coordinate together. Okay, fantastic. So now instead of doing it like this and having these ridiculous 8 variables in here, so let's tidy this up, and I'm going to comment them out as opposed to just, so instead of having this, what I can have is I'm going to say, I'm going to declare, so I've defined a struct with a spelling mistake. It's nice that none of you are pointing out spelling. So now I'm going to declare my coordinates. So I'm going to have a struct coordinate, which is what my struct is called. So of type struct coordinate, and I'm going to have 0.1. And then I might have the same thing, but I'll have 0.2. And then I might have the same thing, but I'll have 0.3, and so on and so forth. And then the 4th point will be 0.4. Okay, amazing. So I've got my struct. Instead of doing some crazy variables, I just have my coordinate points. And now I want to be, maybe let's scan some data in just to see that that's possible as well. So first thing I'm going to do is I'm going to print. Why is everything so badly spaced? Okay, so I'm going to print out, please enter a coordinate. What an opportunity to also use a loop. And we're going to say enter x and y. So we're going to take in 2 at the same time. So I'm going to scan F, and I want 2 coordinate points. So %d and a %d as well. So 2 coordinates to make up 1 point. Yep. I'm going to run out of time of doing a struct within a struct, but yep, you will see it. I'll try. Okay. So %d, and then the same way that I scanned before, I'm going to scan it into 0.1 dot. So the first one, I'm going to put it inside the x member, and the second one into the y member. So dot x, and then the second one 0.1 dot y. So you're doing everything the same, except what's changing is that it's going to, you're telling it what member to assign to, as opposed to just having the variable. Okay, excellent. So I've got 1 coordinate, yeah. Should we do another coordinate? Just because otherwise what's the point? And then we might do something with them, don't know. Please enter another coordinate. And this one's going to go into 0.2, let's say, and 0.2. Okay, I'm going to comment out 3 and 4 just so that we have time to play around with things. And what should we do then? Should we print them out? Should we do, what should we do? What should we do? What should we do? Let's just add them up. Find the difference between the points. Let's do difference. Okay. Okay, add them up. Oh, well, it's too late. I've now wrote difference. Absolute ridiculous. I'm struggling. So %d and %t. And what we're going to do, I'm going too far now because I've got the time pressure now. But I'm going to just subtract them straight away here. I hope that doesn't confuse everyone. Please let me know if it's confusing. So 0.1 x minus 0.2 dot x, and then 0.1 1.y minus 0.2.y. Because the result of both of this is a %d, I can just write what I wanted to do without declaring extra variables, basically. Bit messy. Probably shouldn't do it in week 2, but there we have it. Okay, let's see it compiled. That's not my... And let's run it. So let's do 5, 6, and then let's do 2, 3. And then it's going to find the difference between them. So 5 minus 2 is 3, 6 minus 3 is 3. What are the odds of me doing 2 that are equal to exactly the same? How ridiculous. But how does that feel? I'm just going to touch on another custom data type, if that feels okay. How are we feeling about structs? That poll has shut, so unless you put something in the chat, and the chat is really quiet, which is never a good sign of things going well. Feels okay? Okay, I'm pleased. I swear it does feel better when you start using them. Like sometimes when you hear it for the first time, you're just thinking, what the hell is that? Why is there dots and ampersands and God knows what else here? I promise you, once you start using them, it does become a little bit more clear with what's going on. So I've got 5, 6 more minutes, and I'm going to just introduce you to enums. So don't worry. Jake will cover them again on Monday because I'm going to run out of time to do them in their full glory. So there is one more custom data type why did I just say data? One more custom type that we will learn, and it is called an enum, okay? And so the enum is basically a way to do many hash defines, but do them very neatly, and it's just a better way to do it. So what it allows us to do, and the reason we would use an enum over a hash define, is that an enum follows certain scope rules, and that means that, you know, you can't have an enum that's this is very confusing. Let's go back to the beginning. Okay, so enum is an enumerator, okay? That's what it stands for. So what it does is that allows you to create basically a limited range of values. So like imagine you had days of the week, and you might have, you know, if you tried to hash define it, you might say hash define Monday 1, hash define Tuesday 2, hash define Wednesday 3. And so you'd have 7 hash defines. Whereas an enum, you could just write Monday, Tuesday, Wednesday, Thursday, and it will automatically enumerate them. An enum starts with a keyword, and this is just, I know you're going to lose me, don't worry, but okay, starts with the keyword enum. And then you give it an enum name, and then you will give it the states, okay? So you will say what an enum is, like what it has inside it. So if I define enum weekdays, that means I have and then I can actually say what are the enums in there, okay? So instead of saying and having to remember that I have my 70 hash defines, so instead of, I've lost the plot, haven't I? Bree, I've lost the plot. Yep. Bree's thinking she's lost the plot. Okay, one step back. It's the time pressure. The time pressure. And on someone else's lecture as well. Okay. So let's say I have my normal program. I'm ready to start doing something. I'm going to get rid of that for a second. All right, let's say I have days of the week. I'm going to go back and I'm going to do it properly for the 2 minutes that we have. Okay, days of the week. Let's say I want to hash define them. Going to be a nightmare. So I can say define Monday is 1. Hash define Tuesday. You're probably thinking, why the hell would anyone want to do that? I agree. The best example of enums is computer codes, like error codes, because there's many of them. So it's actually much more feasible to hash define them. Sorry, to have them as enums because it enumerates them automatically. Thursday for blah, 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 blah. So you could really, you have to remember what the numbers are that you've set, okay? And you could also by accident, you know, make changes when you're doing things, right? So there's all sorts of issues with kind of hash defining this ridiculous range of things. So what an enum does is it allows us to solve that by doing automatic enumeration, and what it does is assigns a more meaningful name to a whole state. So again, enums are very good for human readability again, and for making sure that humans don't make mistakes. So instead of doing it like this, what I could do is I will have my definition of an enum. So I'll have my enum, and let's say I'm going to call it weekdays, and I also define it outside of things, right? So Monday, Tuesday, Wednesday, Thursday. I just want you to see what it does before Friday. Why did I have to choose something with 7? Sunday. Okay, great. So I have a weekdays, and I'm so excited about it. I'm sure you are too. You probably got no idea what's going on right now. That's fine. We're rolling with it. We're rolling with it. Again, same as a struct, I will define it outside a main. And then I will declare it inside the main. So then I'll declare that I'm using it. So I'm going to use an enum of weekdays, exactly the same as a struct. So I'm saying I want a struct of type enum weekdays, and I'm going to call it day. Okay, great. So should we see what it does? Then I'm going to set the day to, what's the day today? Tuesday. And if I print out okay, so let's see what happens if I print that out. I know, it's almost all over, don't worry. Oh, what have I done? Oh. Okay, I went too crazy, had too many things going. So the day number today is 1, okay? So it started enumerating from 0. And so this is going to be equal to 0. This is going to be equal to 1, and so on and so forth, right? 2, and so on and so forth, right? So it's enumerating them based on what's going on. And what it means, okay, you're thinking, why the hell would I need this? This is a lot easier to read. Tuesday's a lot easier to read than 2, okay? And same with error codes. You might see like you have a 404, page not found. But you're not going to remember a 404, but you can use page not found to indicate what number it should be, right? So there are advantages to them and disadvantages. And I've run out of time to cover what is actually happening. But just know that there is a magical thing called an enum. If you need to, forget the last 7 minutes of this lecture so that you can approach it again on Monday, because we have come to the end of this lecture. I hope that you're not, don't worry about the enums. It was too late to cover them, and I should have stopped whilst I was on to a good thing. So what I want you to practice when you leave this lecture, I want you to please go home and do your loops, break them, put things inside, outside to make sure you know how they work. Please do a double nested loop so that you can see how they work. And then do your structs. Don't worry about the enums. Jake will do them again on Monday. It was just not enough time to kind of get through them. But thank you all so much. It was so much fun. And I hope you have a great rest of the week. And yes, enums do start counting from 0, just like everyone else. In computing, enums are also special. Thank you guys. Hope you have a great week. And I will not see you on Monday, but Jake will. See you guys.